Hi, hello viewers. Welcome to secondary school chemistry. All right, let's quickly analyze this question we have here. It's a Faraday's question, right? Faraday's electrolysis question. Now let's read together. The question reads 0.5 gram of a divalent metal. The metal is a divalent metal. Was deposited when 0.45 ampere of electricity was passed through a solution of the salt for 30 minutes. That's the time using the appropriate electrode. Now we are asked to calculate the relative atomic mass of the metal, and we are given that Faraday's constant is 96,500, right? All right, so let's quickly analyze the equation. First of all, what are we asked to calculate? We are asked to calculate the relative atomic mass. I will use a capital letter M for that. That's what you're asked to find, the relative molecular mass. Now, what else are we given in that equation? Remember, the equation said that 0.5 grams. 0.5 gram talks about the mass. I'm using small letter m for the mass and capital letter M for the relative atomic mass. So mass there is 0.5 g, right? Or you see g, you know we are measuring for mass, right? And we are told that the metal is a divalent metal, meaning that the charge on that metal is 2. That's divalent. So C here is equal to 2, right? So C is equal to 2, the charge. Now we're also told that the current in ampere that was passed through the electricity was the current is I 0.45 ampere, right? That was passed through in that particular electrolysis. And we also told the time. The time is 30 minutes, right? 30 minutes. But in Faraday's formula, we have to convert minutes to seconds, also hours to seconds. So our unit for time should be in seconds. So we have to convert 30 minutes to seconds, and we simply multiply by 60, because 60 seconds makes 1 minute. So the minute times 60 gives us 1,800 seconds. So we've converted time 30 minutes to seconds, 1,800 seconds. And we are also told that Faraday's constant is equal to 96,500. All right. Now let's quickly use the appropriate formula. Recall that the formula for Faraday's is the mass all over the molar mass, which is the relative atomic mass, is equal to the current times time all over the charge times Faraday's constant. And we also know that IT is also equal to Q, right? The quantity of the electricity passed through. Now, if we have to rearrange this formula to make this big M the subject of the formula, because that is what we're asked to find, then the formula simply will be M equal to cross multiply, right? This multiplied by this, right? The mass times the charge times Faraday's constant, and then all over the current times the time. So we have made big M the subject of the formula, the molar mass. Now let's quickly plug in all our variables here and solve for our relative atomic mass. Very easy. The mass is 0.5 multiplied by the charge is 2, and Faraday's constant is 96,500. Now the current is 0.45 multiplied by the time 1,800. If we simplify all that, let's use our calculator to simplify that, and when we multiply this, we'll get 810 times this 810, and 0.5 times 2 times Faraday's constant, that gives us 96,500, right? 96,500, and when we simplify that, we'll be getting 190. Now, what's the unit for relative atomic mass? Relative atomic mass is simply gram per mole. Very easy. So we have the relative atomic mass of that particular metal is 119. Have a nice day, and if you enjoy watching this video, make sure you subscribe to this page. Bye for now.